This is Madan say here, back here again with next video for you, and this this is going to be the probably second last video of the electrochemistry, where I'm interested to help you with the types of batteries and the common example that we are familiar in our day-to-day life. If you remember your book, if you have seen your electrochemistry last few pages, you will see there are some kind of battery over there. So what right now I'm going to do is I'm going to help you with understanding what are the primary cell, what are their examples, and how they are actually constructed and how they actually work, right? So the topic, I'm damn sure you have understood now that this is about the primary cell. But in case I have not been that much formal, I would say, I hope you are doing fine. And in case you are happy back there, definitely going to enjoy this. So let's see what this, primary cell is. So the first thing I'm defining is what are primary cell. Primary cell, right? A cell or battery, battery in which chemical reaction take place, chemical reaction of a redox reaction convert into electrical energy, and after a period of time, it becomes dead, and cannot be used again, That's what a primary cell is. Let me define it again for you. You know what? A primary cell is a cell where chemical reaction takes place and the energy from the chemical reaction gets converted into electrical energy. But after a certain period of time, what happens? The reactants are consumed completely, and once the reactants are consumed, the reaction stop. Once the reaction stop, no voltage is produced, and that kind of cell is called a primary cell, because after you see that nothing is happening, the only option you have left is you have to throw it off. That's it, because it cannot be reused again. So that's the kind of battery I'm talking about, which is the example is, first one is called a dry cell. It is also called Leclanche cell. Okay, and another one. Let me finish this one first. The dry cell basically consists of a zinc container. So this is a zinc container. And this acts as a anode. And inside the container, you have a carbon electrode as cathode. But this electrode is surrounded by manganese oxide. So this electrode is surrounded by manganese oxide. So this surrounding is what? Manganese oxide. What happened, and the empty spaces here, this is what, this empty spaces filled with paste of ammonium chloride and zinc chloride. And after the paste is filled, this battery is sealed here. So this is your dry cell. Let me repeat and then I'll come to the working of this battery. A dry cell that we are most familiar with any kind of battery is also called Leclanche cell. A Leclanche cell has a zinc container. It has a zinc container, and that container basically acts as an anode. Inside inside, suppose this is a zinc container, and inside the container you have a carbon electrode like that. But this carbon electrode is also covered with magnesium oxide. Manganese oxide, sorry for that. So this carbon electrode is covered with manganese dioxide. So this is the covering of manganese dioxide, and all the remaining spaces between the container is filled with the paste of ammonium chloride and zinc chloride. So this is the paste that is filled inside the primary cell. And after all these three have been completely set up there, the cell is sealed. Now you have your battery, you have your cell ready to use. Now the question is, how does it produce potential difference, and what is the potential difference, right? So for that, talk about this. You know what? There are two electrodes, anode and cathode. Let me write this. This is your positive and this is your negative. So on the anode, oxidation half reaction take place, where zinc undergo oxidation to produce electrons. Why? Because the oxidation number is changing from 0 to +2. And the second reaction, that is redox half, which takes place for MnO2, manganese dioxide. It reacts with ammonium ion and electron, and it's converted into manganese oxide hydroxide, and along with that ammonia is also produced. So this is your redox half reaction. Let me write the oxidation number. There the oxidation number of Mn is +2, but there it is 2, there it is +3. So what is happening here? Reduction. This is your reduction. This is your reduction, and this is your oxidation. Right? So due to the oxidation of zinc and reduction of manganese, a potential difference, shall I write it there? A potential difference of 1.5 volt is produced. So this is what the potential difference is. For this particular dry cell, the potential difference produced is only 1.5 volt. And there is a problem with this cell here. You have to be very careful for the exam, that this cell has a limitation, and the limitation is that its voltage do not remain constant throughout its life. So that is a demerit of this primary cell. Its voltage do not remain constant throughout its life. What that means? There is slight fluctuation in the voltage. So that is why it is not used in almost every appliances or every devices. The next one, which I am going to talk to you after you are done with that, is going to be mercury cell. And inside the mercury cell, the voltage remain constant. So that's why it is very accurate. And that is the reason the mercury cells are used in radio clock, those watches and all. Right? But I'm coming to that. Let me repeat back the thing. What is primary cell? A cell or a battery where chemical reaction take place, and the chemical energy of the redox reaction converts into electrical energy. And once the reaction is over, it cannot be used again. It is dead. So you have to throw it off. There are two examples for dry cell, for primary cell. It is called dry cell, and other one is called button cell. I'm coming to that. How a dry cell is made up of. I have tried to make you go through all that. A dry cell has basically a zinc container, and inside the container there is a carbon electrode covered with manganese dioxide, and all the empty spaces are filled with ammonium chloride and zinc chloride. And after the paste has been filled, the battery is sealed. Now you have your battery prepared. Now the question is, how does it work? On the oxidation part, zinc undergo oxidation, and on the reduction part, Mn undergo reduction, and it produces a potential difference of 1.5 volt. But there is limitation, which I told you, that it does not produce constant voltage, right? So this is about the dry cell. I'm coming to the next part right now. So with that, I must wind this video right here. I would say thanks for watching. Take care, and just say God bless you. That's it.